Hey folks, good morning, good afternoon, good evening, wherever you may be in the world. Really excited today to be doing a AMA and live demo with Thomas Honeyman, who's an amazing developer, and I'll introduce here in a moment. This is a first in a series of YouTube streams we're going to be doing around more technical content, and we're going to really try to target particularly the builders in this conversation. So those with some technical background, but we will try and make it accessible to a broader audience as well. And I hope that'll be an opportunity for folks to take their first steps and forays into programming impact and getting a better understanding of how things work under the hood. So I'm going to bring Thomas up here onto the stage. Hello, Thomas. How are you?
Hey, good morning from here. How's it going?
Pretty well. Yeah, super stoked to finally have you on the stream. I know we've been talking and building towards a real world pact for some time now. And I know people have been following
Yeah.
activity on GitHub and Discord and such, but it's just such a privilege and an honor to have you with us today.
Yeah, I'm excited to be on the stream.
Right on. So Thomas and I actually met a while back in the PureScript communities in programming.
Right.
And when I came on board with Kadena as tech adoption lead about a year ago, I was thinking about developers in just that I knew that I thought were among the most talented and smartest and best people, particularly with the functional programming bent and also with good technical writing skills. And Thomas was the first person that came to mind. I don't know, for those in the community that have been exposed to PureScript, you very likely come across some of his work on the PureScript community and technical communication and writing and blogging. So yeah, Thomas, just super stoked to have you here, and would love to hear just a little bit about kind of your history, your career trajectory, and what you've done before speaking with us here today.
Yeah, like you said, we've known each other for a while now from the PureScript community. That's where I've spent the most of my time in my career specializing in functional languages. PureScript, for those who don't know, is a programming language that's really similar to Haskell, which is what Pact is written in, Chainweb is written in. A lot of blockchain projects, finance projects will use Haskell. So PureScript is a dialect of Haskell that's mostly used in front-end projects. So you're building a UI, but you still want to get some of the guarantees that you get with Haskell. I work on that in a cybersecurity company called Awake Security. So it's a place where we care a lot about correctness, and PureScript really comes in handy there. Yeah, I spend most of my time working on a lot of the libraries in the ecosystem across all sorts of things, from code to render UIs to a lot of the background stuff that you need to make your application work, like all the nitty gritty low level libraries. So it can be a ton of work, but it's a lot of fun. Definitely where I cut my teeth, and it made me really excited when we worked together. And then you told me about Pact, because Pact, I think, like PureScript, does a really good job of embracing some functional principles to make your code easy to understand, reason about, which in a blockchain environment where a mistake can be catastrophic and difficult to fix, it's just of supreme importance. So yeah, excited to talk about my learnings with Pact. It was brand new to me. I'd done no blockchain development before we first talked, but it's been a really cool and a really exciting journey. And yeah, I'm excited to dive in.
Awesome. So just for those interested about the structure today, we're going to first have a few minutes of conversation between Thomas and I, just getting everyone on the stream to get to know Thomas a little bit better, a little bit about his journey and his experience so far. Then we're going to switch over to doing more of a technical presentation and including a live demo. And we'll try and focus some of our time there. And we definitely welcome questions. So I see a question from KDB here. Yeah, definitely feel free to ask questions on YouTube or Twitter or LinkedIn. Those are very easy to see. I'll try and pull up Discord as well and monitor that. But yeah, YouTube, LinkedIn, or Twitter, wherever you may be watching the video, are definitely the easiest at the moment. Yeah, and appreciate the engagement, folks. This definitely is more fun knowing that we're talking to real people, and feel free to ask clarifications or questions along the way, of course. So Thomas, one aspect I'd love to hear is, what was your initial impression of Pact, and what's your impression of Pact now that you've spent some months and many hours actually programming with it?
Yeah, I would say my initial impression was that it looked really nice and really simple and easy to get into, and it's this nice Lispy language, and on the whole, this is going to be great. And then like 5 minutes later, it was just overwhelmed because I had never experienced anything, I'd followed blockchain development, but I'd never actually written any kind of a smart contract or reasoned much about the blockchain environment, which is a super different one from a typical programming environment. It's very constrained. You've got really long transaction times. You have to be really careful about performance, correctness, and Pact gives you remarkably a really small surface area to opt into a ton of really powerful concepts. But even so, as each time you encounter a new little concept in Pact, it can be a long time to really understand like what you're really getting into. One of the first things that I encountered was capabilities, which is a way of constraining the actions that someone can take in a contract or an account can take in a contract. And it's a really, once you get used to it, it's super simple, and it prevents you from having to write a ton of code that would almost certainly have some bugs in it to try and control access to things. But when you've never seen it before, it looks like this one line, and then you just got to spend time to figure out what it even means. So I would say that it can be a bit of a steep learning curve right at the bat, but once you get a handle on Pact, it's really enjoyable to use.
Right on. Let's see here. Oh, and just one clarification for folks in terms of questions for today's discussion. We're going to mainly focus on real-world Pact and some of Thomas's work. So I see Katie, you had a question in the chat. We'll happy to answer that at the weekly campfire that'll be happening again next Wednesday. But we'll sort of try and orient questions specifically around some of the technical content and impact today.
Yeah.
Awesome. Yeah. So another thing I'm quite curious about is, as you've spent more time with Pact and with crypto and blockchain, what was not obvious to you up front that now seems like a pretty big concept or something that you kind of wish you knew at the beginning?
Yeah, well, there's a lot to choose from. Like I said before, I came into this project as an outsider. I wanted to learn how to do blockchain development, smart contract development, and with Pact specifically, but I hadn't done it before, and it's not typical programming. It's not typical. You can just assume that you're gonna have a super fast CPU, and if you've got a bunch of data, you can just shove it in the database. Like, there's a lot of assumptions that go into normal programming that are different in blockchain development. And so as I talk today about things, a lot of it is coming from the perspective of someone who not long ago was a total beginner. And so I'm now at a more intermediate level, but I'm no like Emily or anything like that. So one of the concepts that was not obvious to me at first, and is for me to this day still one of the really tricky parts about developing smart contracts, is that you have to be really, really careful about performance and data storage, because both of those it's just expensive on blockchain. So if you want to perform some computation, one of the things that comes up about Kadena a lot are people talking about block times, like how fast are things getting processed. And I think it's emphasized pretty regularly that like a 30-second block time is good, in the sense that you have to do this computation, but then you have to broadcast it to all these other nodes that then have to reach consensus on it before you go to the next thing, to the next transaction, not within a transaction. And having that in your mind of, I need this to be done fast, and I need it to use only a little bit of data from a database, it really changes your mental model around programming if you're used to doing something like Python or just normal web app development. So putting a front end over a blockchain-based application is very, very different. And that's something that you just have to continue to keep in mind, is how am I going to design this such that I'm not incurring crazy gas fees, I'm not exceeding what I can fit into a block, I'm not trying to just shove a ton of data in the database and assume that I can read it back later in a performant way. That's just something that I think comes to be top of mind for you in smart contract development from the beginning to the end. And that was not obvious to me at first. I kind of took it as like, new programming language, it's distributed, but they kind of are hiding those details from me. So I can kind of take some of my normal programming to it, and less of that is true than I thought at first.
Right on. So moving on towards the projects we're discussing today, namely Goliath Faucet and Wallet. Can you talk a little bit about, well, first of all, curious how you chose the name Goliath, and then secondly, and more pertinently, what made you choose to build a faucet and a wallet, and what's sort of some of the rationale and motivation for the projects?
Yeah, as far as the names go, chain web and like, the web graph structure of it just had me thinking spider names. So Goliath is I think it might be the biggest spider. It's at least one of them. It's called the bird-eating spider, and I think it's like a South American giant spider. So it's just named after that. There's no other reason.
Cool.
I just had to come up with something. The reason that I chose a faucet and a wallet is that they're really common in like test or small demo things. So you might be able to find an analog in a different language. So if you're coming from Solidity or something like that, you might see how it's been implemented there before and have a point of comparison. The other thing is that they're really small, and I'll be clear that neither one of these is very useful. It's purely for you to see from the ground up the basic concepts of Pact. And the reason that I wanted to focus on like the really, really basic stuff is because there's so many new concepts, from key sets to capabilities to namespaces to guards to modules and interfaces and module references. Like, as soon as you start to learn and go through the documentation, you can take off little bites, but you can also end up like with just a fire hose of information. And I wanted it to be something so small that I can explain each one of those things that you're going to encounter in every single Pact contract you run into: namespaces, modules, etc., the formal verifications, capabilities of Pact, which are super cool. I want to be able to touch on each one of those, but without it being overwhelming. Just really basic examples of each one, but in a contract that you can actually run, test, deploy to the DevNet development blockchain that people use for testing. All of that can be self-contained in one project without being overwhelming. So for those who don't know, a faucet is basically a way to request funds from a contract. So if you go onto like the development blockchain for Kadena, nobody has it. There's no exchange. Nobody has like a bunch of money sitting around they're going to send to you from your buddy. So you have to have a way to request Kadena if you want to then explore transferring it or test your contracts out. And a faucet is one way that you can allow this to happen. For the wallet, it's just something that everybody's got experience with. And so when you load up a wallet UI and you want to interact with a contract, building like some contracts as the back end of a wallet just seems like something that people have seen a lot before, but maybe have never thought about how you would actually communicate if the back end is on a blockchain, not just your typical, Square Cash or something like that.
Yeah, awesome. So should we jump into the demo, or would you like to provide any other context or discussion before we do so?
Yeah, maybe just one piece of context, and then we'll dive right in.
Sounds awesome.
So the overall project is called Real World Pact, and the point of it is to start with the faucet and the wallet. Those are the first two projects, but there's three in total. To start from something super, super basic, like I've read some Pact docs, I've done like a little tutorial, maybe I've gone through like the voting DApp. The point is not for this project to be an in-depth tutorial on Pact. It's not going to teach you Pact directly. It's more that I'm going through the docs, I'm trying to write a contract of my own, or I want to test it, and I want to see like, what does an actual project look like that's not overwhelming, that does have a contract, it's got tests, it's got deployments, it's got ways of like interacting through the Pact command line with the deployed contract and reading the results. So it's all real world stuff, but it's pretty small. But it's not the place that you should go to learn Pact directly. It's the place that you should go when you want to see how to translate that to something in the real world. So that's the mental model to come to this with when you come in. The third project we can maybe talk about a little bit at the end is much bigger. It's a decentralized lending app all the way through. So that one is a much bigger project, but we won't talk about it much today.
Yeah,
so
we'll a little teaser for the lending application that Thomas has built out, and for those that are pretty interested, can look at it more on GitHub, and then we'll have a follow-up conversation to dive into that. But today, very, very excited to go into Goliath Faucet and Wallet. And for some people, this may be a first exposure to looking at Pact. For others, it may be a useful exploration after looking at documentation. And regardless, we hope that it'll kind of provide a taste and a launch pad to explore both the GitHub repo that Thomas has built out, which is all open source and freely available, as well as providing more context and really bringing some of these concepts that Thomas mentioned that are mentioned throughout the documentation, and helping reinforce how they're used and how to actually use them in a code base. So this isn't documentation per se, but it's sort of in this space of educational material of like, hey, here's a code base that's well commented that shows you how to use these core concepts. So I think that's really exciting.
Yeah. And there will one day be a core concepts guide that walks through more documentation style explanations of each thing. It's just not there yet. So this is still an under development project. So thanks for doing the AMA, even though I haven't fully got everything together.
Always a work in progress.
Yeah.
Sweet.
So I'm gonna share my whole screen here. Can you let me know if you're able to see it okay?
Yeah, I think we have it up on the stream.
Okay, awesome. So this is the repository, Real World Pact. It is pretty thoroughly commented, so you can sort of guide yourself through this repository. Again, it's mostly meant as a reference for you when you're building your own contract and you encounter a concept and you're struggling with it and you want to see like, okay, how did somebody else do this thing? You can come here and look and see some comments and explanations. Okay. So the project that we're going to look at today is the faucet and then the UI for it. So they're connected together.
And I'll just give a shout out for anyone that is on GitHub. Definitely take a look at the link that we've posted here for the repo. And you can help the project get attention just by giving it a star. Or if you want to follow along and browse some of the code, give it a clone and come look at it with us. But either way, we'll be walking through it here in the stream. So no need to go on to GitHub if you aren't already a GitHub user, but that resource is there, open source and freely available today.
Yeah. And that's another point here is that this is real world. So it is all runnable, deployable. It's not little code snippets. The intention is for you to be able to pull it down, tweak it, go into the REPL files, try changing things around and see how it works. There's some places where I've mentioned like extra exercises you could do to extend it, that sort of thing. But so today, the first thing I want to show off is the contract itself. So in Real World Pact, the first project is called the Faucet contract. And this consists of the basics of Pact development without the UI. This is, you're only focusing on, I'm building contracts, I'm deploying them to Chainweb, and then I'm interacting with them. So the three like tiers that we'll see here is first, we've got the contract itself, which I'll open up. We've then got a REPL file that is the tests for it. So this is an interactive way that you can use with the Pact command line to test out and run different Pact commands and see how they work with the contract that you've developed. And then finally, what we'll talk about is DevNet. I'll just leave it there for now, but DevNet is going to be a big part of your workflow if you're developing real applications. So in the contract, this is in the Faucet contract project under faucet.pact. So the contract itself, it's a very, very simple faucet. It's intended as, I've got this new wallet and I want people to come and use it. And what I'm going to do is with the wallet, administrator keys, like the company behind the wallet, they have some Kadena in an account, and they want to make it so that anybody who signs up for this wallet and generates a new address can request funds to their account. And to set some restrictions on this and make this contract not too simple, we are going to use a few restrictions that are listed out here, these 5. So the first one is that anybody who the wallet approves can request funds from the faucet. It's not just open to the world. So that's one place that we'll see capabilities. We want to do access control. We want to make sure that this isn't just anybody, it's only under certain circumstances can you request funds. A second one is that we want to restrict the amount of Kadena that people can request at one time. So you can't just drain the whole account and say, I want 1 million. You can only do 20 per time that you request funds. And then overall, you can only do 100. And then finally, we'll show how you can make some parts of a contract configurable. So we have made it so that these limits can be changed, but only by the faucet account. And then this also shows off how even if you have an admin account that's taking sort of protected actions in a contract, you can still make restrictions on the contract, such that the administrator can't do some things, that even the administrator is barred from taking some actions. For example, the faucet account can't decrease anybody's limits. Once it's been increased, it's it. And then finally, you can return funds to the faucet. So in this contract, just because of time limitations, I'm going to kind of skim through it. But the main thing I want to show you is that it's fully commented out. And so this contract is a good self-contained tutorial to writing one of these things yourselves. You can copy paste it and then just swap out sections that I've written for your own code, but keep the comments as a little bit of a reference for how to use this. So yeah, we'll go through a pretty brief summary here. Pretty much every contract that you write is going to involve writing at what's called a module, like a packed module. The module is a collection of tables and functions. It's an interface that somebody can communicate with on-chain, and each module has a name. So when, for example, you want to transfer Kadena from one user to another one, then that's done in the coin contract that Kadena writes. That's like a very foundational one that's on Chainweb. And when you are actually, a wallet is transferring funds from one user to another, they're calling the transfer function from the coin module in that coin contract. And so in here, we have basically the same setup. We go through somewhere in here, we go through and create our module. And this is called the Goliath Faucet module.
I just want to call out and celebrate, Thomas, that you have a 277 comment introduction before the first line of code, and that is absolutely amazing. Like, this would make Donald Knuth very happy as a great example of literate programming. Yeah, this is really wonderful to read, but it's not super fun to edit. Definitely don't do this in your own contracts because it's a lot of writing in this contract. The later contracts in the project have much less because you've been introduced to everything. But now that we're inside the module, I'm not going to go through the whole module, but I just want to show you a couple of packed features and then show you how the comments explain how they work. So each one of these modules, it's got a name. So this is how you're going to refer to it on chain. So if you want to transfer funds from the faucet, you're going to send a transaction to Chainweb. It's going to be packed code that says, hey, I want to call Goliath Faucet dot transfer or request funds. So anytime you're calling a function in a contract that exists on chain, you're always going to namespace it with the module and then a dot and then whatever the function is that you're calling. In the next section, I'm going to show you how we actually send requests to Chainweb and get responses back. I'm going to just show one capability, one function, and a little bit of formal verification and then move out of here just to keep it a little bit tight. But we can see a typical module will include defining some tables. So this is recording who are these accounts who have requested funds and that we've sent funds to. And this is the data that we're storing about it. In this case, how much have you requested? How much have you returned? What are your current limits? And so this is kind of like typical programming. I've got a database. I'm storing information in it that I can refer to in my functions. So this is typical programming stuff. One thing that's not typical, but is super cool, is that Pact allows you to specify what are called invariants on the data in your table. So in this case, I'm saying that it should never be possible for your account limit to be exceeded, that you have never requested more funds and not returned back funds
that exceed your account limit. And this just looks like a simple little line here, but this is one of my favorite things about Pact, and something I think is so cool about the language that truly sets it apart from other ones, is that Pact will, in the REPL, which we'll see in a moment, will formally verify this. It'll use Microsoft's Z3 theorem prover to explore millions of inputs to this function and make sure that it's not possible with the way that I've implemented all of the rest of my functions in this module for this to ever be false. Like, this must always be true. And if it can find a way, which happened to me while I developed this, if it can find a way to invalidate this, to give some input to a function or call this function, then this other one, then the original one, it might find a complicated path, but it will find a way to invalidate this if possible. And it'll tell you how it did it exactly. And so you can trace that back through your own code and fix it however you need to. And so it's a super powerful feature. Anybody who's getting into Pact development, I definitely recommend leaning on the formal verification system as much as you can. So yeah, this is with tables. So this is where you're storing your data. Then you have, so one of the main concepts is, where do I store my data? A second one is, how do I control access to that data and to different functions? And then the third thing are, what are the actual functions that people can call to change that data? And so one of the things that was a big learning experience for me was to think of Pact not as a general programming language, but kind of as a database language specifically. It's an interface to this distributed database, and you're kind of just doing these computations to read and write to your tables and enforce access over that. So that can help with the mental model. So this is a long section about capabilities, but one thing that we have here, this is a capability, this def cap. And what it's saying is, when this is used, when I say in my functions, hey, I require the capability set limit, then what that means is that the administrator must have signed the transaction that where this capability is being requested. And so a capability has a name and then a body, and the body is the condition that has to be satisfied. So we'll see in a moment, if you want to change your limits on your account, you want to say, hey, I do want to be able to request 1 million Kadena. It will only be possible for that to run if the administrator has signed off on it and said, hey, yep, the set limit capability is granted to you. There's a ton to know about capabilities, so I'll leave it there, but there's a lot to learn about it, and it's a really cool and a really powerful feature. The final main part that you'll see in most modules is a collection of functions, and this is stuff that people can call to manipulate the database or get information from it. An important thing to note is that databases in Pact are not public. The only people who can access it, read, write, etc., the only place that it can be accessed is within the module itself. So if you want to read a field from the database, the only way is if the person who wrote the contract gave you a function that reads from the database. It's not public, which is, in my mind, very, very good. It's good to have controlled access to your data. So this is what a typical function looks like. We have the name of the function. So this would be Goliath Faucet.requestFunds to call it. A few arguments to the function, and then you've got the function body. And once again, we'll see that it's pretty common at the top of a function to leverage that formal verification once again. So this is, again, specifying a few properties that are saying, hey, when this function runs, these things should never, ever be false. So for example, you should never be able to request a negative amount of funds. That's going to make our data inconsistent. So this will enforce that it's never possible to do that. So I'm just gonna stop here. We got some reads, some writes. This is a long module, even though without comments, it would probably only be 100 lines. So if you're interested and you're curious about how you actually write one of these contracts, I definitely recommend coming into this module. It shows you each of the main things that you'll always see in one of these Pact contracts.
Awesome. Yeah, what I love about this contract is, that you have such a narrative to it, so that even if you aren't a programmer and this is your first time looking at like literally a line of source code, you could go in here and you might not understand everything that's going on, but you could narratively follow and understand conceptually how this is happening. And so I think this is a really wonderful introduction for those that have any interest in Pact or in programming and Web3 and blockchain. whether you have experience in Solidity or Python or just experience in English. You can go to this link and poke around, and I can promise you, you will walk out having learned a lot. So I'm going to post this link here for those that want to, bookmark it or save it for later, because I think it's a really, really cool resource and should be super fun.
Yeah, thanks for saying that. I've definitely made an attempt to motivate each thing that we build. It's what's the problem? Like, why do we want to build this? Like, what's the thing that we're trying to solve? And then like, how do you translate that into Pact? And I think that really helps. It's not just a dry bunch of features get thrown in your face. It's very much each one's motivated. Why do we need this? And a lot of each one of these directories has a pretty long README that explains like what are the different files, how they fit together, how they work. So we'll see a little bit more of that in a moment. So awesome. There's two other things that I'm going to show today. The next thing is the REPL file. And then the third thing will be actually deploying this to DevNet and then interacting with it and then having the UI interact with it as well. So a REPL file is super common in Pact development. It's basically a super lightweight way to load your contract, call functions from it, and then test that they are producing the results that you expect. But the REPL file is more than that because you can use it for interactive development. This is a Lisp, so if you've ever used something like Clojure, REPL-driven development is a really big process in those sorts of communities. You can, I'll kind of leave it there, but if you read through the Pact documentation and you look at some of the REPL-driven development in Lisps, you may find a new way to work if you haven't done that before. But one of the other things that happens in the REPL is that it's kind of like a very lightweight simulation of what this is going to be like on Chainweb, as if this was running on a single chain, this contract. And with that, you get a bunch of REPL-only functions. So you can't call these in your contracts, but you can call them in the REPL. And they're super useful for understanding how your contract is going to behave.
Just briefly, for those that haven't heard the word or phrase REPL before, it's basically an interactive environment. It looks similar to a terminal. If you've ever opened up terminal on your computer and executed a command or two based on some online instructions, or maybe you're a programmer and this is very familiar to you. But it's an environment similar to a Jupyter notebook or other interactive environments where you can write code, define a function, call it, get results. You could write out a list of numbers, add them up, average them, and then write a new function that instead took the median, and then you call the median function. So that's the TLDR and what a REPL is. Please carry on.
Yeah. And actually, why don't I go ahead and load this up? So now hopping over to my editor, can you see it okay?
Yeah, I can see it great.
Okay, so see where I am. So let's go. So we got the REPL file here. So this contains all the code, but to get into it, I can call Pact, and then I can load. I haven't done this in a while, so let's see how it goes. Okay. So this gave you a bunch of output here. This output is all just responses from stuff that I've done in the REPL file. But I was saying before that you can do stuff like call Goliath Faucet, or I can do something like describe module. It's supposed to be a string. So you can kind of interactively like check on stuff in your contract. So this, for example, describe module is a Pact function that literally will print out the entire contents of a module that you're interested in. So this is pretty useful if you want to look up something on chain. You saw somebody made a call to some contract, you can look it up with describe module. There's a bunch of functions like this that the Pact REPL gives you. But for now, I'm just going to show you the contract itself. What I was saying about the REPL is that it's a lightweight way to test things and interactively do things with your contract, but it gives you some extra functions as well Some of them are env gas, which lets you see the gas consumption of every function in your contract. And so, or calling a couple of functions in a row. This is really important because you want to know how much it's going to cost to run your contract. You should definitely use this all the time in your testing because you can get some pretty nasty surprises where you thought something was going to be a cheap 20 gas operation, which is basically free. But because of something about the way you wrote it, it actually costs 10,000 gas or something. And those can be a nasty shock for you or your users or affect your business if your contract is ending up costing a ton of money to run. But the way that a REPL typically works is you're going to load in your contract, and then you can start just calling, like you're just writing pack code in here. msigs is a way of signing transactions. mdata is a way of including a payload in a transaction, which you can do on chain web. But everything else in here is just explanations of how do we formally verify a contract? How do we see in here, how do we actually like call functions? So here we're requesting funds for our user. And then how do we test it? The big way to test it is this expect function, which lets you say, when I call this get balance, I expect its value to be this. This is your way of unit testing contracts. So this REPL file is full of like little mock transactions. I want to pretend that I'm requesting funds for this user. It's been signed by the faucet. And I expect that to succeed and for them to have received the funds. And you can write all those unit tests in here. If you look at any of the official Kadena repositories as well, you'll notice that they use REPL files pretty religiously to exhaustively test their contracts. And many of those will include a magical line verify. And this is what runs formal verification. And so when we ran this in the REPL, that load successful and no output when I just ran it, that means that my formal verification passed. We're good to go. Every assertion I made has checked out. And yeah, we're good to go. So that's the REPL file. It's a bit smaller, but I would say that if you only take one thing away from this whole thing, I would read the packed file and I'd read the REPL file. They contain the basics of what every packed project is going to include.
Yeah, and I love that you showed that verify line because I don't think we've shown it on a stream before, and this is one of those features of Pack that I think is so cool. And people maybe have heard folks on the Kadena core team describe formal verification before, and maybe it hadn't made sense. And hopefully, after today's session, now you can say, "Oh, wow! When we were looking at the faucet contract, it enforced certain guards around. Hey, you can only request amounts that are greater than 0." And there's this property in terms of the funds requested in terms of the change or the delta that happens, and this ensures that the faucet functions properly, and you can't request negative funds or do weird stuff that could break things in unique ways. And then, as Thomas said, that single verify line as a sort of language level feature is then kicking off this fairly complicated software stack that then runs auto-magically, millions of different entries or values and exhaustively tests the code to verify that property is true. And I think this is one of the things that I get really stoked about just as a programmer, that I hope that we start to see these kind of features in other languages as well, because this is powerful stuff.
Yeah, I'll just give a quick demonstration of it as well. So when you write a formal verification property like this, that's just an assertion of what you don't ever want to fail, but it doesn't actually do it for you. It's not going to put lines into your code that actually prevent those situations from arising. You are still necessarily, you have to do that. And so, for example, here we can see we've got a property that the amount requested, which is somewhere up there, a argument to this function, has to be greater than 0. But if I don't actually enforce that with this enforce function that will prevent the transaction from succeeding, then it won't actually, like, it'll catch that.
Yeah, load failed.
Yeah, oh no, I changed something else. So this is giving me a gas error, which I can just comment out because it's not relevant. So I've got some checks in here that I'm not using more gas than I expected to use and that kind of thing. And verify. Oh, I'm gonna have to change that line because I'm enforcing elsewhere the amounts. So this is not triggering. So actually, in this case, the verification is actually helping me see that I've got redundant enforcements in my function and could have saved a little bit of time. So see what happens here if I can take out a little bit more of my function.
I think this is one of the interesting things about verification, formal verification, is that sometimes we have this mental model of how our code actually works that differs from how the code is in reality written.
Yeah. Well, not the best demo here because
the demo gods are striking the course.
I have too many other enforcements here. So taking out my right is causing my other enforcements to check. You'll notice that this faucet is full of enforcement checks, like all over the place. Tried to make it watertight as a good demonstration. So unfortunately, I've maybe over enforced it. So if I had more time, I could check. There's plenty of models.
If you had more time, you could probably break your code so it allows something illegal.
Yeah, I'm sure I could break it if I needed to. But I want to move on because I want to show off something different, which is so like the step 3 of testing is one, I've got my contract, I've written it, I've used the REPL file. I normally write them together. I'll write the packed file and the REPL file at the same time. So I've got my tests happening at the same time. But then eventually you do want to actually deploy it. You want to actually say like, what is this like when it's running on chain? Does everything work the exact same way that I expected? What about when it's on multiple chains? So at some point you do want to really run it. And Kadena has this project called DevNet. And this is really important. This project is an ad hoc local version of Chainweb that you can run. And so I would definitely check out this repo if you are doing any pack development. And we can see that this project, if you clone it locally, it gives you some helpful commands. One of them is DevNet. So I've got some things in here to help you start and stop DevNet and then run it on your own. So we've actually already started it a little bit before this call. And I wanted to show off a feature of packed where the packed command line will let you, just with the packed executable alone, send requests to your local Chainweb node and get responses back. I've written a little helper tool in here that lets you just do it quickly. It's called Faucet Request. And what Faucet Request lets you do is take any of these request files in this request directory here. These are all files that you can send transactions. So I'm sending actual packed code to the Chainweb node with this metadata. This is who's paying for gas. This is how much money I want to transfer. These are who has to sign it and what capabilities they have to sign. All the stuff is thoroughly commented. So this is a legitimate transaction that you can send on chain. And this is true of mainnet as well. You can use these request files with the packed executable to send requests to a Chainweb node. And so here I can, for example, do a faucet request to do a local request, which is when it's not getting written to the blockchain. And I can look up the faucet details. And so this actually is sending a request to my locally running blockchain, and it's looking up the account details for the faucet account. So it's going to print out, if you're writing an API or a front end for this, this is the payload that you get back. This is the exact JavaScript or JSON that you'll get back from a Chainweb node. So it's a really useful way to experiment with sending requests, receiving responses. We can see as well that, for example, one that I've written is user details. So this is what a failure looks like when you send a request and your packed code doesn't work. This is what happens when the Chainweb node has rejected it. And the message that's happening here is it's saying, you tried to look up the details for this account, but it doesn't exist. So in my application, I can respond to this however I need to. There's also some requests in here that allow you to send them. So one is request funds. This is going to say, hey, I want to take this user account and I want it to ask for some funds from the wallet. I just signed up. I want some money. Please give it to me. And maybe this has been. Always be careful with your demos. I want to, yeah, I want to request funds. This is one of the more perplexing errors you will see from Pact, because it doesn't always mean that the transaction time is invalid. But I can try something else. Well, at least my local requests are working. I'm not sure what's going on here. Well, for anybody who wants to run this locally, which you are totally welcome to do, I will fix this. I just updated Docker and pulled the recent chain web node, so maybe something has changed there about my transaction times. So I will fix that and make sure that you can run it. But the point of this is that you should be able to run these requests, and that is sending a request to the chain web node and getting a response. What it's telling me is that something is malformed about the request that I sent. If you ever want to see,
Yeah, I think my guess is that does the request YAML file have the TTL field in it?
I think I'm appending that later, but maybe it does have a TTL. Yeah, 600. So
yeah, I know
unfortunately,
that in the
we don't
past
have a
I've
ton of
always
time.
I haven't been very sophisticated, but I've in the past usually just manually put in my date timestamp like that Python prints and spits out. But
one of the easiest things is to just put that in manually. This is attempting to make it reusable.
Yeah, more fancy and reusable. That makes sense. Well, no worries there. I've definitely seen that same error before and mucked around with my date time stuff. But hey, folks, this is a clear demonstration that Thomas is doing it live here and showing this. And
yeah,
I think overall live demos are always tricky. But I think the fact that you have the confidence to show off all this stuff and go through line by line of the code is really telling of just the rigor and how well put together everything is.
Yeah, it can be tough, live demos. Always be careful with these things. So this, just so that maybe not raw. This is another helper that's in here called format only. So these request files, one thing that can be tricky about them is you write this YAML file that describes the transaction that you want to send. But this isn't actually what you're sending to the blockchain. What you're sending instead is this kind of complicated looking JSON payload, which looks like this. And I'll zoom in a little bit. So it's this long like JSON payload with SIGs and key set values, and it's this big JSON string. And so I can see that I've got a weird gas price in here, and that my timestamp might be weird. So I'll have to check on what's going on. But if you ever want to debug what is actually the request that I'm sending, and is it like if I'm getting an error, like is there something wrong about the way I formatted it? You can, with the Pact executable, see like what is the literal JSON payload that I'm sending and validate it yourself. Don't have time to do it right now, but I will be doing that after this call. So the very last thing that I want to send, I know don't have a ton of time, but the last thing I want to show is that there is a whole separate project called the wallet. And the wallet is it's connecting a front end. There's no Pact code in here. This is only front end code, but it shows you how you can bind to a contract, like the request funds function that I was just calling from Pact code. This is how I would write it in JavaScript and then send a request, writing it all in JavaScript code to the chain web node. And so I'll show what this UI looks like. This is, again, it's totally runnable on your own. It's called, what is it called? This menu will tell me Goliath start. So this will start up a UI for me. Yeah, this request. So we can see the request is failing here as well, which is odd because it was working. So I'm going to stop DevNet and restart it, but I'll just show you a little bit of the UI. So this is what the wallet looks like. It shows you your typical, all of my balances on all my chains for my account that I've got. I can request funds from the faucet. I can return funds to the faucet. There's also this little, you can pretend to be the administrator of the contract, and you can adjust those request limits and account limits. Basically, every function that exists in the faucet itself in the contract is also represented in the UI here. So this gives you a visual way to interact with a packed contract that's running on a development blockchain locally. Any transaction that happens here, this is the list of all the things that happens. The first thing that happened on page load is that we tried to request some funds and failed. And then you can see in here the same thing that we were seeing before. We got a request error with a validation failure. And then this is showing you everything, all the information that we sent to the chain. So I'm going to try and start DevNet again. And while we wait for that to start back up, I can maybe answer any other questions. I know we're getting kind of to the end of our time.
Yeah.
But, that's how.
So yeah, folks. So basically, just to give a quick synopsis and review, we have two code bases that we've touched on here. There's the faucet contract, which has importantly the pack code and some of the REPL code, as well as some transactions that are in these YAML files. And then there's a second code base, which is the Goliath wallet, which is really showing off the JavaScript, Kadena.JS, and I think TypeScript interface to using Pact and these libraries. And so this is maybe particularly applicable to front-end folks. So in some sense, what we have here is the faucet contract is kind of like your classic backend. And the Goliath wallet is then the front-end application that interacts with that backend. So it's showing sort of this nice self-contained building on itself. And I think we are scheduled for another 8 minutes or so here. So if any folks have questions on concepts or things that you want to go into more detail on, please feel free and post them, and we're happy to get around to them. Otherwise, I can have a few questions for Thomas as well.
Yeah, and just really quickly, something got out of sync with DevNet, but our transactions are back.
Oh, baby.
Yeah, there we go. So if we load up, we can see, we've got our pending transaction. You can see in the network what it actually looks like to be sending this to Chainweb and get a response back. And then when that transaction concludes, you'll see this is all the stuff that you sent, but you can see what is the actual JSON that is being sent back to you from the Chainweb node. So this is a good way to see that low level, like what am I sending? What am I getting back? If I'm getting an error, like what are the possible error statuses, all that kind of information. These modals will, if for example, I try to request 70 or whatever, it might fail because I'm over my limit. So this, for example, I just tried to request 70, but you can only request 20 at a time. So this is like the full call stack, the error that Pact gives back to you. The pertinent message being from our contract that we wrote, 70 is above the per request limit. So if you look at the fact that at the faucet contract, you'll see all of these error messages. They're the error messages from your contracts as well. So you got to be careful about the sort of error messages you write because they do come through to the user as well. So I'm happy that it's working again. So
the triumphant return. So basically this interlude of the bug we just saw was really just an excuse for you to show how to debug things. That's what I'm getting.
yeah, that's right. So
the demo works.
that happens is that you can do DevNet clean at any time. If you're like, all right, I deployed all my stuff, but now I changed my contract, but it's on the blockchain forever. What do I do? If you don't want to deal with the hassle of like upgrading or deploying something new, you can run DevNet clean. It'll wipe out your database to a clean state, and you can do it all over again. So this is a really useful thing if you have, say, integration testing for something you're going to deploy live, is to deploy it, run it for a while, and make sure that if it's still working in 10 days, you can clean it, do it again, make sure it's good to go. So, yep, that's about it.
Awesome. Also good for live demos. Incredible.
Yeah, good for the live demos. I'm glad I could reset that.
Very, very cool. So I guess I had a question around, I think more the JavaScript interface. I was curious if you could just show a little bit of that and speak to you know, how do you sort of handle the separation of concerns of what ideas and code do you kind of do in JavaScript and what ideas and code do you do in Pact?
Yeah, for the faucet, it's kind of everything's in Pact. The JavaScript is just pulling from the contract itself. The main things that you're going to have to orchestrate are one, just be aware that your requests are going to take a long time, because you might send a request to request funds or whatever, and just understand that in your UI you're going to have to pull for results for a while, because you have to wait for it to be mined into a block and then tell you what your response was, or fail out. So that's one thing. Overall, I mean, like you said before, it's your backend. It's where all the data lives. Like your source of truth for any data that's really important in your app that needs to benefit from this decentralization, that stuff should live in your Pact contract. You should have it in your table, and then you should have a function that exposes, you're able to read data from the table through that function. It's a lot more convenient to just have Pact give you like an object back of all the information that you want, versus having to have your JavaScript make like 6 calls to different functions to figure it out. But definitely, if you think of Pact or of Chainweb as a giant distributed database, and Pact is a database language for interfacing with it, then I think that kind of keeps things pretty clear that anything that's reading, writing data close to the database, that stuff's all in Pact. Anytime you're aggregating stuff from different contracts or whatever, all that stuff is going to be orchestrated in JavaScript. Yeah.
Awesome. Maybe I'll pull off the code here so we can finish just for the short conversation. I'm curious, when you've built out on the front end side. So you highlighted this one consideration of, hey, you do some action with the blockchain, it may take tens of seconds or a minute or two, and this is longer than many user experiences on the web in general. So there's sort of this UI challenge of saying, hey, how do I sort of keep the user reassured that things are progressing, keep them updated, and that's one aspect. What are some of the other things that you think for a front-end developer now getting involved in Web3 that might not be obvious that they should be aware of?
So one thing to be aware of is that when you call this, and this relates to the point that you just had, when you are sending a request to Chainweb, you're sending some Pact code to Chainweb. And so as a front-end developer, that can be kind of weird. You're not just sending like a JSON payload typically. You could, but it would just be really tedious to write, because inside that payload is Pact code. That's what Chainweb nodes accept. And so that can be kind of a weird experience, is like, how do I organize that in my code base? It's not just like a bunch of JSON requests with objects. Like, I need to be able to construct Pact code for the different requests that I have. One thing you can do is you can literally read in Pact code from text files, like all of those request files that we had. Those can be written such that they just pull in little like .pact files that contain what you want. But otherwise, the Kadena.JS has this, and I wrote a utility in real world Pact for it, to just write snippets of Pact code in JavaScript. It's kind of weird, but you're writing Pact code, essentially Lisp, but using JavaScript syntax and sending that. That's probably the weirdest part of it. But the other thing I would say about like responsiveness is that when you send a request to a Chainweb node, you should always send a local request first. So local is when it's a read-only request. The node evaluates it, returns a response, but it doesn't broadcast it to anybody. Local requests are different because there's no gas limits, there's no gas fees at all. It's because it's all just happening on the node locally. So you don't pay anything. You can send as much code as you want. It's different from a send request, which has all these limitations on it. But the send request is the one that gets broadcast, it gets written to the blockchain, it's in the history. But what people don't necessarily know, and what I didn't know at first, is that you send a local request as a preview of what your send request will be like. And if there's an issue with it, your user gets feedback immediately. The local request will tell you right away. Or if you want to show your user what you assume is going to happen, you can give them back the result of the local request, saying like, hey, this is what the node says the result is going to be, even though it hasn't written it everywhere else. So you can use that as a way to kind of like what the stock market does when you like make a sale, like they are kind of lying about how quickly they're settling those financial transactions. But they tell you that it's done and it's good to go, even though it could, once it actually finishes, it could not actually have gone through. And so it's a little bit of a cheat, but it's a way to keep your things looking responsive with a
Yeah.
prediction of what you expect
So
it will
if
be.
you're writing a game and you want to be able to let the user purchase an in-game item and immediately access it, maybe you're comfortable saying, "Hey, well, the local node said the rights, looks good to
Yeah,
go.
right succeeded. So
So hey, here's access
yeah,
item," and then a minute later, you sort of presume the user wasn't malicious and didn't do a double spend or something, and then
yeah,
it actually settles in blockchain. Um, I want to take
yeah.
one
Depending on
last.
how important it is, but yeah,
Right. Maybe you don't do that if it's you're about to hand over the keys to your car or something.
yeah.
Want to take one last question from the audience, then we'll wrap. But a question from One Hit
Cool.
Quitta, asking about what's the significance of being able to, I'm going to say to my words, execute or use pack code from JavaScript. Why should we care about that?
Yeah. So I guess the first thing is that Pact isn't compatible with JavaScript or Python directly. What
Yep.
happens is the chain web nodes that make up chain web, they are what is distributed about this distributed database. What they do is they supply an API, like a typical HTTP API endpoint. So a place where you can send code to be evaluated. But the chain web node is the thing that is doing the evaluation, and it only knows about Pact. It can't take some Python code and translate it to Pact or anything like that. When I was talking about writing Pact code in JavaScript, I more just mean like JavaScript code that formats into a Pact string. It's still Pact code ultimately that gets sent off. It's just that it makes it easy to write the Pact code in your front end versus having to like have it written in these files that you load in later. So the main thing there is just it's convenient that you can do this in your JavaScript code. But what's important is Chainweb is only ever dealing with Pact code. There is no such thing as like a JavaScript, front end for Pact or something like that. Ultimately, what gets executed is always Pact code.
Yep. So just to bring that home, for example, Thomas showed off with the faucet contract a way that you could send a request to get funds from the faucet, and then did the same thing using the Goliath wallet. Now,
Yep.
I think what's useful about using Pact code from JavaScript is that if you're a web developer and want to provide an interface where someone can go on a website and do this functionality, that's how most people are going to interact with the blockchain in Web3. Right. So
Yeah.
if you were to be an app developer and create the best DEX in the world, but it was only accessible from the command line, you probably wouldn't have the same kind of user base as if you had a nice web interface. So even though at the end of the day, what's happening is sort of technologically, hitting the blockchain, the same transaction is happening, whether it was initiated in Goliath or initiated via the REPL and Faucet. One of those experiences is much more user friendly.
Yeah. And so there's that gets called like an SDK or like sometimes a front end to a different programming language. So you might have all kinds of different programming languages that make it easy to write Pact code from that language, but you're generating the Pact code. So you might have like an Elixir package or like a Haskell package or a PureScript package or a JavaScript package. All of them are just doing the same thing. They're creating some Pact code that can then be sent to the Chainweb node. But the Chainweb node, it's always Pact.
Yeah.
But it makes it easier for like a JavaScript developer to be like, I can write it with the JavaScript and then I can send it off, and it's easier to integrate into my app.
Yeah, makes sense. Well, Thomas, thank you so much for your time today. Thanks for battling and defeating the demo gods. That was very impressive.
Yeah, always a trouble.
And once again, folks, really encourage you to check out the Real World Pack repo. It's absolutely fantastic and has a really thorough work through and write up. And I think that anyone that attended today's session is well prepared to look at that code and get an understanding of what's going on. And if those are your first steps in Pack development, welcome. We're so excited to have you. If this is your next step in becoming a more intermediate developer, more power to you. Or if you're already an experienced developer and just want some inspiration for how to better organize your files and what some best practices might look like, another wonderful resource. So Thomas, thank you so much for all your work on Real World Pact. It's super exciting. Thanks for your time today, and can't wait to have you back to talk about this lending platform that we have alluded to, and we'll just leave as a final tease for those that are interested in a more intermediate completed app.
Yeah, a little compound clone. So it's real world stuff. Excited to show that off.
Awesome. All right, folks. Thanks for tuning in.
Thanks so much.